Okay, let's look at how on your lab how you're going to do a couple questions related to the calculations that you have to do. And so on your lab, there's going to be a part where it says calculations, determine the order of the reaction, write the rate law, and calculate the rate constant. So I'm going to show you how to do that with this video, and then I want you to do your work. You can do it on a piece of paper and then insert your work in here because it's kind of hard to do it on the computer, I feel. So just do it on a piece of paper and then just insert it down here below number 3 will be fine. Okay, so let's go back to how to do that here if I can find the right thing. Okay, here we go. So you have to look at your data, and you'll be looking at the data in this table right here that we collected in the lab. And so you're gonna and here I just have some made up data that I have. So here's how you're going to do it. So here's how you would find the order of the reaction. So if you remember in this reaction, we're basically taking hydrochloric acid plus calcium carbonate. And so the hydrochloric acid is AQ and the calcium carbonate is a solid. Now we don't really need to worry about what's over here, although we did collect CO2 gas, and that's where we got this data. But the rate law is only dependent on the molarity of HCl. And so what we're going to do is find the order of the reaction, okay, with respect to HCl. So here's how you do it. You just pick any molarity, but the way I do it is always take the bigger number. So let's just pick the 2 molar one. So we're going to take the 2 molar, we're going to divide that, and I'm going to pick a smaller one, times 1 molar, and then I'm going to put this in brackets, and I'm going to put a variable. We'll just call it n. Now n stands for the order of the reaction, and what we're going to be finding is this exponent. That's the order. And so what we're going to do, that's going to be equal to, now look how I got 2 molar. I'm going to take the rate that the 2 molar produce, which is 0.2018. I'm going to divide that by the rate that the 1 molar made, and I get 0.1007. And so 2 molar divided by 1 molar is 2 to the power n. That's going to be equal to 0.2018 divided by 0.1007, and roughly, if you round a little bit, which you're going to have to do with experimental data, you get 2. So 2 to what power is equal to 2? Well, n equals 1. Now this should hold true if you do it for any trial. So we could take trial with the 4 molar, and we could divide that by, let's just say, the 1 molar, and that's going to be to some power that we don't know. We'll just call it n again, and that's going to equal, okay, now it's really important, 4 molar, what's the initial rate? 0.4039. I'm going to divide that by the 1 molar, which is 0.1007. And 4 divided by 1 is 4 to the power n is roughly going to equal 4. So no matter which trial you use from your data, you should get the same number every time. So the order of the reaction in terms of HCl, it's a first order. The exponent that you get, that's the order. So it's first order reaction. Okay, then you're going to write a rate law. And to write a rate law, you just write the word rate. So rate is going to equal K. That's called the rate law constant. Okay, and then you take the substance, which we're just concerned about, HCl, and we put it to the power, which it's first order, so the power is 1. Okay, so you just write the word rate equals K. You just write that every time when you're writing a rate law. Put the substance that you're studying, which is HCl, in brackets. The brackets mean molarity, and then you put it to the order that you just figured out, the first power. That's how to write the rate law. Okay, the last thing that you need to do is solve for K. So what you'll do to solve for K, you'll just take any trial, it doesn't matter which one. The easiest one is going to be the one with 1 molar, so that's the one I would use. And so the rate, we know for 1 molar, we already have that, so we're just going to plug that in for rate. So 0.1007. Now what we're trying to do is solve for what's called the rate constant K. We're trying to figure out the value of that. I already screwed something up, so I'm going to start over. All right, with this, when you do this, you always need to show your units. So I'm going to show my units because we want the rate constant K to have some units with it. And so the units were kilopascals per second. So I'm going to include that. So I just substituted that in for rate. Now I'm looking for K, and then that's going to be to the concentration that we measured, which is 1 molar, okay? And the 1 molar is to the first power. Now the thing is, I got to get K by itself, so basically I'm going to divide both sides by 1 molar. I'm not going to show the brackets, shouldn't have showed them here. I'm going to divide both sides by 1 molar, and what I end up getting is K is going to equal 0.1007 kilopascals per second over molarity. And that is how you get K. So you need to do 3 things. Find the order of reaction. All right. Write the rate law. So this is how to do number 1 on your calculations. 2, write the rate law. And 3, find the value of K. All right. Those 3 things are what you need to do for your calculations. If you need to watch this video over again, watch it over. Okay? That's it.